Hi guys, I am Dr. Nandhabalaji. Today we are discuss about the nanomaterials, electron density, free electron densities. How to calculate the free electron density and highest electron orbital, highest electron densities, bulk material in physics materials. The number of electron states per unit volume per unit energy at E, energy. This energy density is a factor in many of the electrical properties of solids. Independent of the dimension L, the expression can be applied to the bulk materials. So the materials equation is N of E into curl E is equal to G of E F of E into curl E. Like as number of particles per unit volume with the energy between E and E plus curl E. It's equal to density of states or number of energy states per unit volume in the interval, and the distribution function or probability that a particle is in energy state in energy level. The density of states is essentially the number of different states at a particular energy level that electrons are allowed to occupy, the number of electron state per unit volume per unit energy. This represents the number of electron states per unit volume per unit energy at energy E. This energy density is a factor in many of the electrical properties of solids. That the result is independent of the dimension which was chosen above, showing that the expression can be applied to the bulk material. Since electrons are fermions, the distribution function is the Fermi-Dirac distribution. This distribution determines the probability that a given energy state will be occupied but must be multiplied by the density of state function to weight the probability by the number of states available at the given energy. The determination of how many waves there are to obtain an energy in an incremental energy range dE can be approached with the quantum mechanical particle in a box. The energy for an infinite walled box is E is equal to N1 square plus N2 square plus N3 square into H square divided by 8 ml square. The energy can be expressed in terms of R and vice versa. R is equal to 2 into square root of 2 MEL divided by H. Whenever the energy is E is equal to H square into R square divided by 8 ml square. A calculation is made of the density of the electron levels in metal particles of small radii alloying with the energy band structure. The size dependence of makes the Fermi energy of a particle depends on its radius. In this graph shows the energy is increases, the density of state is increase in parallel material. We are know 4 different type of structures: dotted structure, wire structure, well structure and bulk material. If it is a dotted material, the dotted material is increases to gradually. If wired material, it increases, energy is increases, the density increases, and the energy is decreases, the density is decreases. The graph shows the like as different structures of 4 different types of nanomaterials. In this kind of density states belongs to each and every material, nanomaterial have a different applications. Thank you guys.